Hello guys, welcome back to the Embedded Rust on RISC-V YouTube channel. And in this session, I'm just gonna discuss about a few of the errors I found out and fixed on the UART driver. And also I would also discuss few of the changes related to the code restructuring, or I have done some changes to make the code look elegant, and I just learned few things which can be modified to make the code look neat and nice in Rust. So that's what you're gonna see in this. So first, this is the Git repo, and if you go to the dev repo, and let me see, I just want to show the difference which I have already submitted. So there's one commit which I merged. So the most important change in that was to fix a bug, because when I tested when I tried to send a string, sometimes I received an incorrect string. So when I found out that this mask should be 00 at the byte, because in the TX data register, the last byte is the data byte that has to be sent. So if you see here, the mask will mask only the last 4 bits. So this is a major change in the UART.rs file. Otherwise, if you, let's go to this file here. So let's go to the trunk and source GL. So at the end of the last session, this is how the code was. And if you see here, so this is the serial.rs file, and this is supposed to have the methods and structures for all the serial devices for UART, and there's a UART configuration structure. And I defined few traits, but if you see, these are all like multiple traits for, so traits are nothing but signatures, right? So all this could have been grouped together as one single trait. So this will also work in Rust, except that these all are for UART. So these are all needed even for, let's say that if I extend this to SPI or anything, so all this can be grouped like this. If we go to the dev branch, this is where I have submitted the change. So here, so just a serial trait, and because the serial trait can be for UART, the same can be implemented for SPI, and so on. So, and inside this trait, I have grouped all this functions for UART. So that looks more neat and nice than this, and I didn't know before that a trait can have more than one function. So that's the information. That's why that's one of the change which I have already merged. I'm also making a few changes which are not yet merged. So the code, every time I read a memory mapped register, I used to do like with the namespace like PTR and read volatile, so and so. But I just tested this. What I did is like created a pointer for the TX data register, which is part of the UART 0 memory map. So just to refresh, if you go up, so this is the constant, because this is a raw pointer, it's a fixed memory map address. So this is the base address for UART memory map or UART memory map registers, and it has the TX control, RXT, and TX data. So I need to cast that as constant U32 first, because read volatile takes a parameter takes a pointer as it accepts only const type or const pointer. So because it has to just read, so it makes sense that it just needs a const. But whereas the write volatile needs a mutable pointer so that it can write into that. And I also see that a raw pointer can't be casted or can't be typecasted into a mutable pointer directly. For example, if I change this to a mutable U32 directly, then it will throw an error. Whereas I see that first, if I cast into a const U32 and then as a mutable U32, then it works. And this is so for read volatile, I pass this R, and you see here R dot read volatile, and for write I write with W, which is a mutable pointer. Okay, and this one is not yet merged. I'm still working on, and if this works for this, then I need to modify for modify in other places as well. And I'm also planning to extend the string. Before it was just welcome. I'm trying to change to welcome to learn RISC-V. That's a minor change. And I'm also planning to add the support for PLIC, platform level interrupt controller, and interrupts. Then I want to run this same print RS application to send a string through serial port. But now this doesn't use any interrupts, but whereas in future I want to use interrupts to send the data through UART. Okay, so now let's see the changes I made for the PLIC. So for PLIC, so I have my learn RISC-V channel, which is linked with this, is where I discuss about all the assembly coding for RISC-V. And so basically, okay, let me save this first. So first of all, this PLIC is specific to RISC-V, and PLIC stands for platform level interrupt controller. So what I see from the spec is that PLIC has three functionalities. One is to enable any of the interrupt sources. So in RISC-V, a core can have a set of interrupt sources like for example, these are all the list of interrupt sources for in FE310 SOC. So there are totally, I think, 52 sources that can interrupt at the platform level. So this is not like core interrupt sources, because as you know, in RISC-V you have interrupts that are handled by each core, like the timer interrupt, and I see you have a software interrupt at the core. So those interrupts would be handled by a specific core, so there is no arbitration there. But whereas at the platform level, let's say there is a SOC which has 2-3 cores, and you have these one or more UART on the board, and then if there's an interrupt occurs, then there has to be an arbitration which core has to process this, and so on. So, but for as far as the FE310 is concerned, it's just a single core, but still the PLIC has to be there as per the spec. So these are all the three major interfaces I have I'm implementing and have still in the process of, but by the time when you watch video, I hope that this would be merged. If not, just remind me in the comment. I would be happy to merge this. So first one is to set the threshold. So threshold is the value. So for example, for FE310, these are all the interrupt priority levels. So 0 is do not interrupt, and the level 1 is highest interrupt all the way to the level 7, which is the lowest threshold. So excuse me. So if a core has to be enabled to be interrupt only by interrupts which has a priority higher than that, that's what you set in the threshold register. So for example, if you want this core to be interrupted only by interrupts which has a highest to all the way up to a level 3, then you just set the threshold as 3. So that is one functionality, one primary functionality of PLIC, allowing the threshold which plays the role of a gateway, I would say, to allow a set of interrupts based on the priority. And second one is like a particular source. For example, at the interrupt source level itself, you can completely cut off, enable or disable that source to interrupt. That is the second function. The third one is like setting the interrupt priority for the source. Here in RISC-V, what you can do is like you can fix, for example, you can set UART 1 with the highest priority level, and so on. So that's what is like you can set the interrupt priority for each source. So these are all the 3 interfaces I am planning to, or I'm implementing on PLIC for the FE310. I have separated the PLIC from the core interrupts. So as far as the interrupts, so it's also still in progress, and if you see right now, the interrupt handler is incomplete, and it's very primitive, I would say. Yeah, where is the interrupt handler? All it does is just clears the claims and completes, but so far I have never used, or the execution would have never jumped into this trap unless I make the or crash the system or crash the processor. So this is the in progress M mode trap handler, and so once the M cause or the cause of the register is found, it has to be checked if it is an interrupt, asynchronous interrupt, or an exception. And if it is a synchronous exception, these are all the exceptions that are possible in FE310. So I am meant to fill this code, but the main objective for me is to, what is that, sync UART and external interrupt. This is where the PLIC comes in. So as I said before, first these are all the core interrupts, and I have to fill this functionality, and then that should be mapped to if there is any external interrupt, and that should call this external interrupt processing. Here again, we have to collect the interrupt ID from the claim register and see if that is UART 0, or that can be that there has to be more matching values here. And then even in for UART 0, it has to be checked if it is the RX interrupt or TX interrupt. And all these are the work in progress. As I proceed, I would update the code into the GitHub. Okay. So yeah, thanks. And thanks for watching this video. And if you are interested in more videos on embedded Rust on RISC-V, please feel free to subscribe and hit the like button. As and when I find time, I would keep posting on this. Yeah, thank you.